Here we're multiplying two rational expressions that have terms that are not monomials in the numerators and denominators. So in this case, the first step, which incorporates factoring both top and bottom, is a very important one. So we're going to factor each of these terms one at a time. So my first numerator, x squared minus 4, you may recognize that that is going to be a difference of squares, which factors as x minus 2 and x plus 2. My denominator, noticing that I have a coefficient of 1 in the front, indicates to me that this is going to be a simple trinomial. When I factor it, I'm looking for two numbers that add to give me 12 and multiply to give me 36. And those two numbers are 6 and 6. So I'll write those out as such. Moving on to my next fraction. Once again, I have a simple trinomial in my numerator because the coefficient is 1, not written in. And I'm looking for two numbers. In this case, they add to give me 9 and multiply to give me 18. Those two numbers happen to be 3 and 6. And if you add 3 and 6 together, you get 9. If you multiply them, you have 18. Finally, in my denominator here, 4 minus 2x, it's just a simple common factoring, and I can bring out a 2, and I'm left with 1 minus, sorry, not 1, but 2 minus x. So there's the first step, and now I have to state any restrictions on the variables. So if I look at my denominators, I'll notice that my restrictions over here require that x cannot be equal to negative 6. So x cannot equal negative 6, otherwise I get a denominator of 0. And in this denominator, well, I cannot have x equaling 2, because if x is 2, this difference becomes 0. So those are my restrictions. Step 3, cancel any factors common in the numerator and denominator. Now, is that possible here within each fraction? Well, the first fraction has no common binomial terms. The second fraction, same thing. So what I'm going to do is now multiply them together, which really just means writing my answer over one fraction line. So what I'm going to do is I'm going to copy all of this, take all this stuff right here, paste it here, and all I'm doing is really, I'm going to erase that negative multiplication sign. This fraction will now be multiplied with this one here, and there you have it. The product of two fractions together is just one fraction with the numerators multiplied and the denominators multiplied. Now usually we do not see the 2 at this point. Okay, any coefficients that are not in a set of brackets will be usually put in front, but it doesn't mean it's wrong the other way it was written. And now we can look for any common factors. Well, in this case, it's quite evident that the x plus 6 over here and this x plus 6, for example, can cancel out. We don't have another x plus 6, but if you look closely, this 2 minus x and this x minus 2, I mean, they're the same term, just that the order is reversed. So here's what I'm going to do. I'm going to interchange the 2 and the negative x here in the bottom. But when I do that, if I put x first and the 2 afterwards, so I have x minus 2, I have to take out a negative sign. Okay, that's a little trick we learned a little bit earlier on. So what does that do to my expression? Well, let's copy it out right here. So now I have x plus 2. Well, I have x minus 2 as well. Okay, that's the first one from here. Then I have x plus 3. And this is all over negative 2. This I'm going to make negative because this term here I'm going to make x minus 2. And then I have the x plus 6. Notice that the order of the binomial terms, I've interchanged them, but remember, multiplication is commutative, so it doesn't matter how I write the order of a multiplication. And then you can see here that the x minus 2 and the x minus 2 cancel out, and you are left with x plus 2 and x plus 3, and that is all over negative 2 x plus 6. Now you might see in textbooks the final answers written where the numerator is multiplied out. I mean, this is fine technically, there's nothing wrong, this is 100%, but you may see them expand the numerator. So you may see your final answer written as x squared plus 5x plus 6 all over -2. The denominator is usually left in factored form. There you have it. So there's your expression with everything multiplied out. Your restrictions stated. If you want, you can copy them again and state them at the end. So I can put them here if I like. And that finishes your problem.